Hello and welcome to a new series of videos for PLC Ladder Logic Learning by Practice. In the first part, which is this video, we'll talk about a little bit about the wiring and the ladder logic basics, and then we will go into probably 2 or 3 examples. Part 2 will concentrate on the timers and the counters. Part 3 will have a PLC, a real PLC, and we will program it and we'll see the action in the PLC immediately, how it goes on with the PLC programming. 4 and 5 we'll talk about productivity and DES launch, which is Automation Direct software for programming a PLC. All of them are in ladder logic. And in part 6 we will talk about some tips and tricks which will help you hopefully in your ladder logic or programming a PLC in general. I've been doing a PLC programming and cabinet building for quite some years. Some of them, they are very complex with full redundant. Some of them is very simple applications. So as a bit of history, Dick Morley in 1968, he invented the ladder logic as a mean to convert the wiring which is we will do with normally open, normally closed, timers and so on, into a system or a PLC or a programmer logic controller or a device which is actually can be programmed in a similar way of doing the wiring. So is it the only thing which is we can program the PLC with? No, right now IEC 61131 define 5 ways of programming PLC. Depending on the PLC brand and the PLC CPU, you may be able to program more than one language or only one language you have to follow. Some of them actually you can have bits of pieces of ladder logic and function block in the same program. The PLC now in these days had been advanced very much, and now you can have a lot of thousands of IOs, completely a lot different than what had been started at year of 68. Now it's kind of magic PLCs. They can do a lot of things, and you can interface with many equipments and interface with HMIs. So this is the basic wiring. When we do any wiring, we do 2 power lines, the live and the neutral. In this wiring I did a couple of live, so L1 and N1 is specifically for the lamp test, and L and N is the main power for the circuit. This is a winch circuit with mechanically and electrically interlocked contactors. So let's start from the beginning. When you do any wiring, what you do, you have the L, which is the live or the 24 volt, and the neutral or the 0 volt in the DC case. Then you have on the left side, from left to right, you go into conditions, which is normally open a push button here. In this case, here is a contact from a relay, here is a pressure switch from the machine, and so on. So if the power can go through the first contact and the second contact and so forth, you go into until you energize your output, which is in this case is a relay, could be a lamp. In ladder logic, we follow the same concept or the same philosophy of having a power rail, and in the power rail what's flow is the logic, not, of course there is no power here, but the logic goes through a contact and goes through another contact until it reach the your output or your required action. Notice here we have a normally open contact and normally closed contact. What does it mean? Because this is very important, and I hope you concentrate on the next slide to understand what we mean by normally open contact and normally closed contact in ladder logic. So in ladder logic we have a condition. If this condition is met, then we go to the next one, and if the second one is met, we go to the third until we reach the action. You can have a series condition in series or in series and parallel. So in this case, how many contact you can have here, or many columns or many conditions? Again, it's based on the PLC brand and the PLC CPU. So in the same brand you can have multiple options here. Branching, which is mean you can branch from the rung. Each one of these we call them rung, and when you branch it, you can maybe have another additional condition or contacts in this area. Maybe you cannot. That's depend on the PLC brand. So what is we mean by normally open and normally close? This is a digital input card, and this is another digital input card. In the first one, digital input 1, here we have a normally closed contact, and in already closed the contact, and in this DI card we have an open contact here. So in the first rung we have DI1, which is this guy. If you have power is applied to the channel, you will have the LED is on. That means this contact here is true. I like always to talk about true and false more than open and close or normally open, normally close, because to me it's much easier to understand. So meaning if you have power to the terminal, so the input is on and the LED is on, then the normal open contact representing this DI is true. Meaning the normally closed contact for this DI is false. Now, if you have a digital input which doesn't have any power in it, so it is off, the LED is off on the card, that means the normally open contact represented on the ladder logic is false in this case, and the normally closed contact for this input is true. So now you can understand what is normally open contact, normally open or normally closed contact means in the ladder logic. Please, maybe you have to see this back again to make sure that you understand this point, because a lot of things are based on this slide. Now we talk about a two-directional motor. You want to control one motor with two direction, right and left or up and down. So what you do, you have in the ladder logic, let's look at the wiring first. You have a switch 1 and switch 2. This is for the direct, this is for reverse, and then you take one contact from the second contactor and put it in the line for energizing the first contactor, and then another contact from the first contactor in the line to energize the second contactor. The reason for that, if this contactor is energized, you will not be able to run or energize C1. And if C1 is energized, this is open and you cannot energize C2. So that's what we call it electrically interlocked. So now in the PLC, what we will do, this is DI1, DI2. DI1 is the switch for reverse or direct, and 2 is the other one. So this is right, this is left, this is direct, this is reverse. Push buttons. If you receive the push button for direct and then it is not running on the reverse, this one will be true, this one is true now, so you can run it in the direct direction. Once you are in the direct direction, you cannot run it on the reverse direction because this link is open. So this is how you apply the ladder logic design for a two-directional motor. So what kind of contact we can use? So far we have seen those two, normally open, normally closed. There is exactly the same idea, but it's completely different. This we call it differential. What does it mean? It means when the PLC look at this contact, it will consider it true only if it changes status from off to on. So it will be on for only one scan because the second scan is already on. So it will not consider it as true. The second contact only will be true if it is changed from on to off. Some people will draw, some software will draw it this way, some software will draw it that way. Comparators you compare two registers. So one of them is more the second or less the second or equal the second or does not equal the second. All of them will give you two conditions, false or true. Invert is inverting what signal coming in here. So if the signal coming here is off, then it's become on. If it is on, it will become off. If it is true, it will be false. If it's false, it will be true on this side. Intermediate contact is not available for all softwares, but if in any PLC, what the PLC will do, it reads all the inputs, then execute your ladder logic and then writes the output. But if you put the intermediate contact in the middle of the software, of the rungs, what it will have, it will do, the PLC will stop at this point, executing the PLC ladder logic, go to the input, this specific input, read it, and update its only status of this only input, and then continue scanning the rest. So now what kind of action you can do? You can have a series of out and set. Of course, you need a reset for the set. You have a pulse output, you have OR out, and then you can have a break, end for, next, go to, and so on. So there is a lot of commands you can have them as an actions. Timers and counters are very, very important for any programming. That's why we will have one specific video only talk about timer and applying timers in real scenarios. So let's do more circuits now in ladder logic. So this is the circuit of motor control wiring. You have a start push button and a stop push button, and then some protection if you would like, and then you have your contactor. When you press the start, what happens is the power will go all the way until C1. It will energized. Then once it's energized, R1 or C1-1, which is this contactor contact, will be energized. So it will be self-powered, self-maintained circuit. Once you push the stop, the system will cease and C1 will be de-energized. This is how we will apply it. We have a start and a stop push buttons. The stop push button is normally closed. The start push button is normally open, and this is how we draw them. So now the stop push button is on, so the signal here is true or on. Of course, the start is open, and Y1, because nothing happens here, is open. DO, we don't have any output, goes to the contactor. So this is the first scan, this is the status. Now in the second scan, the PLC found that you have already pressed the start push button, meaning the power goes flowing through to the first channel. That means X1 is true in this case. So the PLC, when it scans and execute the rung, found this one is true, found this one is true, so Y1 will be true. So it will turn the Y1 at the end of this scan, and your contactor will be energized. Now in scan 3, because Y1 in scan 2 was on, this become the status of it become on. So now this is true, true, true. Nothing happened, nothing changed, and still Y1 is energized. Now you release the push button. What's happened is in this scan 4, the PLC will find that this is off, but it's still from the previous scan Y1 was on. So it will continue latching this output. So the output will latch based on the status of Y1. In the fifth scan, the PLC had seen that you have pressed the stop push button. That means you open the contact for the second digital input, the X2. So the PLC, when it's run, X1 is off, X2 is off, then Y1 is off. So it will turn Y1 off at the end of scan 5. Even Y1 from the previous scan was on, but at the end of scan 5, Y1 will be off. Scan 6, because Y1 is off and we still have this guy is off, so Y1 will be off as well. Now you release it, so you return power to second channel, and we'll reach the first status, first scan 1. So we return back to scan 1. So I hope now you have the idea of how to program a ladder logic. But just to continue and make the picture complete for you, if you would like to do any motor control, you need to add all your protection in series with the stop push button, same as in wiring. So any one of them will open, let's say phase loss, frequency, up and down, under voltage or over voltage, any one of them will release the latching Y1. Now this is the motor control wiring in the PLC programming in the ladder. Do we have another alternative? Yes, we do. This is a much easier one, and you can understand it very quickly. You have a push button, which is the first input, which is the start. What it will do, it will set the output. Now X2, because it was connected all the time, then you need to take the reverse. You need to take the normally close contact here, so it will reset the Y1 when this one is open. So set and reset is an alternative to the out Y1. We'll look at how the PLC execute the program. In traditional old PLC, you have all ladders in rungs, and they are one the second and one in the second and so on. And what's happened is that you have to make sure that you have interlocks to deactivate all this section in the startup, and this section only will be activated in the shutdown and so on. Now the new PLCs, they added something else. They added some kind of stages or subroutines or sections. Each company, they call it different. You can execute the ladder in this area only one in the first PLC scan, or each scan it will execute it, or once every second scan. Sometimes you go from a ladder logic in this area to another ladder logic in another area. So now again, this is based on your programming language. Maybe in the 4th and 5th video, we'll discuss this in more details. So in PLC, what's happened is the PLC will read the inputs, then execute all your ladder logic, and then writes the outputs. It does some stuff before and in between, but we will not look at it now. So let's take it a simple form of it like this, and then we'll go here. What's happened in the PLC, it goes from the left to right in each rung and from top to bottom. So let's look at this example. Someone had decided to write out Y1, out Y1, out Y1. So he repeated what the command as out for Y1. And this is not recommended really. But let's see what happens. X1 is on, so Y1 is on, X2 is on, and the PLC updated in the Y1 as on again. Now X3 is off, so Y1 will be off. So at the end of the result, and the PLC ends all the execution, this is always will be the Y1 status. Regardless how many on and off above, it doesn't really matter. What matters is the last out in Y1. So meaning all this doesn't have any effect on the Y1 whatsoever. This is very important that we don't use out more than once in the same segment of ladder logic. This is another example to show you how the PLC will react and execute the program. Y1 is off because in the previous scan X1 was off and Y2 was off from the previous scan. Now the PLC will proceed with the next rung and found that the X2 is on, so it turns Y2 is on. Now the third rung, Y2 status will be on. So if it's even in the same segment, because Y2 in the middle had been changed status, so the next rung Y2 becomes true or 1 or we will see this in more details when we have hands-on on the PLC. We will try to do these examples to see is this really how the PLC will react or not, and how you can do it yourself to make sure this is the PLC reacting. Now there is another command you need to know about. It's called OR out. This is different than the out. So the OR out, you can write it in many places in your PLC program. So any one of them, turn the Y1 on, you will get Y1 on. So it looks like it is OR. So any one of them on, Y1 will be on. If all of them is off, then Y1 will be off. So this is another command called OR out. Now, this is a very tricky part and important. What if we switch the rung sequence? So instead of the start then the stop, we'll use the stop and then the start. So this is, we call it a safe design to have the start and then the stop, and this is unsafe design to have the stop and then the start. Why? So in more details, what's happened is that if you have a PLC, you have the start push button is pressed, and you have the stop push button is deactivated. That means the wire is cut or someone pushed the wire. So what's happened is this is become active. So now even you press the X1, the wire is cut. So this one is active again. So the PLC will set Y1, and the next rung it will reset it. So at the end, Y1 is off. So if you press the start while someone pressed the stop or the wire is cut, the motor will not run. Now look at the other way around. Now you are pressing the start and pressing the stop at the same time. So in the first rung, it will stop, which means it's reset Y1, but in the next rung, the PLC will turn Y1 on. So the PLC will run or get your output on as long as you press your start push button, regardless of the status of your stop push button. So this is very important for two things. First, you have to think about the sequence of your rungs. The second, you have to think about the test you need to apply for your PLC after you finish your programming to make sure that there is no issue like this will happen. This is again last example, we'll have it in this video, is a tank level control. We'll do it by set and reset. You have two level switches. This level switch at the bottom, when the level is below the level switch, the contact will be on. If the level goes above, the contact will be off. And here again, if the level goes below the switch, it will be on. If it's above the switch, it will be off. We'll use this in set reset. So meaning the level when it reach below the lower level switch will be on. That means I need it to normal this way, which is normally open. When it become true, I will set it. Now the level goes above. That means still this one is in the on. So it's will on. So this one will be off here or false. Only when the level reach above the level to high level switch, which is become the level switch become off. That means this is true. It will reset Y1. So your level will go between below the level switch low and above the level switch high. So it's always will be between both of them. Exactly the same what we did in the motor control. We did the same X1 and Y1 and Y2, X2 when this is a Y1. What we said that the Y1 here is your solenoid, which is adding water to your tank. So this is exactly the same as your motor control circuit. The only thing is that here, if your level switch off at this location and on top of it, you can change the contact here from normally open to normally closed, and this one as well. So you can see now how easy to change the ladder logic if you changed the level switch or added another contact for your level switch. I think by this we have concluded our first part, and thank you for watching, and see you in the part 2. And if you have any suggestion for any further videos in this series for PLC programming and ladder logic, please let me know and let's communicate. Thank you, and see you in the next video.